Hello students, this is the third and final video in this short collection. Just giving you some pointers on nomenclature. Okay, so we've looked at covalent compounds, we've looked at S-blot methyl ionic compounds, or any ionic compound that behaves like an S-blot methyl ionic compound. Finally, we're going to look at ionic compounds other than S-block ionic compounds. So ionic compounds where the cation has a choice of charge or can adopt different charges. And we see that this is the nomenclature family of Stock notation. Stock notation are after Professor Stock, but they refer to Roman numerals where the Roman numeral represents the charge adopted by the metal in the compound. So for example, number 27, I can immediately see a Roman numeral 2. This means that copper, although capable of forming more than one type of charge, in this compound has adopted the +2 charge. So this makes sense, having a 1-to-1 definite proportion between copper and sulfate. We know as a polyatomic ion, sulfate is -2, and I could actually solve for the Roman numeral 2, because if I know sulfate is -2 and I've got one copper, copper must be +2 because the sum of the charges must be 0. So copper 2 sulfate, the charge on the cation is +2. Mercury 2 chloride here, number 29. I know that any halide is a -1 charge. It needs 1 electron to fill its valence shell. And I have 2 of them. So what could possibly offset 2 single negative charges? Clearly a +2 charge. So mercury here has a +2 charge, and I represent that as a Roman numeral 2, which is Stock notation. Tin 2 bromide, I have a tin with a +2 charge, which satiates the 2 single negative charges of each bromide ion. You can do this with polyatomic ions too. So here in number 8 we have cobalt 4 bisulfate. Remember, you could also call it cobalt 4 hydrogen sulfate. Personally, I prefer hydrogen sulfate because it's just more logical, but bisulfate is also used and would be acceptable. We know that sulfite is -2. Hydrogen sulfite, therefore, is -1 because we've added an H+. And I'm told I have 4 of them, so altogether, these 4 bisulfates in the parentheses have a net -4 charge. I've only got 1 cobalt, so what charge could that 1 cobalt possibly have to satiate the 4 single negative charges? It has to be a +4. So we know it's cobalt 4 bisulfate or cobalt 4 hydrogen sulfate. That's pretty much all there is to it. So again, just to summarize, once you know what type of chemical you're looking at, whether it be a covalent, okay, I'm going to use my prefix rules, an S-blot methyl ionic compound, not a prefix in sight, no stock notation, no need. Or I'm going to look at something where the metal has a choice of charge in any compound, then I would have to offset that choice, I'd have to specify which choice was chosen. So I'd have to use stock notation. Once you know what type of compound you have, you can follow the appropriate rule, rather than just trying to memorize names and not recognize, oh, there's different types of family here. I would say one thing I'd point out, although I tend not to bother with it on my assessments, you might bump into it in your reading, things like cupric perchlorate. So the suffix "ic" is an old nomenclature convention that you might see. To be honest, I would say it's a relic, but there are lots of relics still around. Not mentioning any names. But you can have "ic" or "us," OUS versus IC. And this refers to oxidation state of the metal. So if you, for example, have the choice, so let's say copper commonly can adopt a positive 2 charge or a positive 1 charge. Clearly positive 2 is greater oxidation state than positive 1. And we associate the ic ending with the greater oxidation state. So cupric perchlorate, the ic tells us it must be copper 2 versus cuprous, C-U-P-R-O-U-S, cuprous perchlorate, that would be copper 1. This has been superseded by the stock notation, the Roman numerals I referred to earlier. So we would just conventionally call this copper 2 perchlorate. But again, there are people still alive that would call this cupric perchlorate. So as an homage to them, let's make sure we're aware of what they mean when they say cupric perchlorate. Acid nomenclature, to be honest, my strategy, and all I can tell you is my strategy is just to memorize the names. Let's look, for example, at this cluster of acids here, so 87 through 91. You look at them, what do they have in common? Well, the structure, they all have a proton, where proton means H+. If you have one proton, you're monoprotic. If you have 2 protons, you're diprotic. If you have 3 protons, you're triprotic. That's great, but the mono, di, and tri don't factor into the nomenclature. What element you have that's the cation or the non-proton part? Well, here you have Cl, here you have sulfate, here you have phosphate, and here you have perchlorate. Notice that the nomenclature typically ends with acid. That's logical, that's useful. It immediately alerts you that you have an acid. So hydrochloric acid, you notice, is a mixture between hydrogen and chlorine. Sulfuric acid is an acid, so it must have protons, but it's based on sulfate. Phosphoric acid is an acid, so it must have protons, but it's based on phosphate. If you know from polyatomic ions, the phosphate is -3 charge. You must have 3 protons because each proton has positive 1 charge. So the Joseph-Proust definite proportion comes out of your knowledge of the polyatomic ion. Phosphate again has -2 charge. We have 2 protons to counterbalance that charge. Hydrobromic acid, we know bromine or bromide has a -1 charge, so therefore we just have a 1H. So I would just go ahead and memorize the name of acids. That's certainly how I do it, and ultimately I can only give you tips on how I would do it. There's definitely acids that you're likely to bump into in Gen Chem. There are acids that you will never ever bump into unless you happen to bump into them in a specialized part of your career moving forward, so there's probably no point worrying about those. The common acids, usually a textbook will say common acids, learn these. You'll find all the common acids in this handout. You'll find them also in your textbook. If you're in doubt, you could Google common acids in general chemistry, and you'll notice the same list will come up. It would be sage advice to memorize that list. I will leave it there. Any questions, contact me through Canvas. Otherwise, I will see you in class.